Greeting everyone. Welcome to the presentations of the an IoT to programming the Internet of Things projects. My name is Phan Nguyên, and today I'm gonna present about a topic related to the subjects of the IoT programming. The topic of this project is an IoT automatic water tap system. The instructor uh, it consists of Nguyễn Đức Hoàng Hà and Đỗ Thị Thanh Hà, and student made this project is me, Phan Chuyên Nguyễn. Turning to the agenda of this project consists of 6 parts. The first is overview, second is the introduction, third is the methodology of the project, four is the experiments and the summary and project assessment, and finally is the reference of the projects related to. First of all, turn to the overview of the projects of an IoT automatic water tap system. Consists of the person who finished these projects, uh, student ID, full name, student email, and class. And the project names is an IoT system. The programming environment consists of software and Arduino IDE, Blink, on online visual paradigms for drawing paradigms and graph related to demonstrate how this project works, Microsoft Word for the report writing, and the Microsoft PowerPoint for making the slideshow for presentation. Programming languages consist of C++, and the task is to build an IoT system to solve a specific business need in life. Turning to the introduction of this topic, consists of 2 parts. First is the applicational significance of the project. As people have seen that in the current era of Industry 4.0, the development of automatic water tap faucet system is becoming increasingly suitable and necessary in today's world due to various factors driving the demand. This is a new technology developed to prevent unnecessary water usage by controlling the water flow. It is also becoming popular in crowded places such as shopping center and restaurants, or maybe the airports. And therefore, the use of this automatic system is gaining more and more popularity. Concerning the applicational motivation of the project, the reality demonstrates that water is an extremely crucial factor for human beings, with numerous activities related to water. In daily life, the use of water becomes highly important and essential in various fields such as households, industry, and agriculture. A study from the World Council website has revealed that an average person needs about 5 liters of water daily to survive in a mild climate with minimal physical activity. The agriculture alone can consume about from 75 to 90% of the available fresh water in a region. Globally, we consume about for 4 trillion cubic meters of fresh water annually. It is evident that the demand for water is immense, but the utilization often lacks efficiency and may lead to the wastage of precious resources. For this reason, research on automatic water faucet system can contribute to innovating the water management strategies and technologies. And based on like the Internet of Things emerge as the solution to these issues. Like sensor technology, automatic water system can heavily depend on this. For the problem statement of the project, for 2 parts, the input and the output of this system. The input is an object that close to an infrared sensor that can detect is there anything close to the faucet that they will put out the water for the consumer to use. And for the output is the water for customer to use. It is simply for that. Turning to the mythology of the project, I should consist of several definitions related to this, like the Internet of Things. The concept of this involves connecting various types of devices, from smartphones, coffee makers, and washing machines, to light, smartwatch, and virtually any imaginable object in the world to the Internet. This connectivity extends to components of larger systems, even machinery on offshore oil rigs, which can remotely manage. IoT primarily revolves around the use of small, energy-efficient computing devices, such as household doors connected to local network or the internet. Nowadays, IoT is closely associated with the advanced technology that leverage these connected, compact devices for a wide range of applications in fields like automation. Turning to the faucet, there are two types of water faucets serve for the purpose of regulating the water flow. Despite its compact size, the presence of a water faucet holds a significant importance in our daily lives. It plays a crucial role in creating favorable conditions for various water-related tasks, from using house to operating devices in the bathroom. Furthermore, the design and aesthetics of the water faucet can also impact the overall beauty of a room and specific elements within it. Currently, there are many types of water faucet in that is available on the market, but they can be broadly categorized into two types: the traditional water tap and the smart water tap or IoT water tap. And the traditional faucet are the conventional manually operated ones that can be used for a long time. They typically feature a handle or knob that user can turn to control the flow of water. These faucets are reliable and straightforward in design. On the other hand, their smart faucet represent a more modern and technologically advanced option. These faucets are equipped with sensors or touch controls that can allowing for hands-free operation. Smart faucet often comes with additional features such as temperature control, water-saving modes, and connectivity to the smart home system. They contribute to the convenience and efficiency of water usage, aligning with the trends of automation and connectivity in contemporary living. For uh, the development board design for this project is the Node MCU ESP8266, which is built open on ESP8266 20E firmware and ELUA. Essentially, this type is a complete Wi-Fi chip with a powerful TCP/IP protocol stack. The Node MCU simplifies the development process by compactly integrating the ESP8266 into a feature-rich board. It includes a microcontroller capability of the Wi-Fi connectivity and an integrated USB to serial communication chip, which making it convenient for the developers design and program the board. Turning to some a thing that can control the way of the water to turn on or off, that is a relay. Using a relay with the ESP8266 is an excellent way to remotely control an AC household device. The basic components of relay concludes 6 pin 1, 2, 3, 4, 5, and 6. The input is from 1, 2, and 3. DC plus is connected to the positive pole of a 5V power source. DC minus is connected to the negative point of 5V power source, and in is a input for activating the signal. High or low, like the levels selected through a jumper. For the output reference from 4, 5, 6. This NC is normally closed interface. COM is a common interface for both open and closed states, and NO is a normally open interface. That is uh, how a relay consists of the components for it to operate this system. For the sensor related to this project, that is infrared sensor FC51, emits and detect the infrared radiation. This type of sensor is a part of the electrical magnetic spectrum with a wavelength higher than those of visible light and typically invisible to human eye. Here are the functions of the pins on the FC51 infrared sensor. For the VCC, you will see that in VCC pin, this provide input voltage of 3 to 5 volt. GND pin for the ground connection input, and for out pin is you can transmit the output signal from the sensor to the circuit board. Turning to the water pump to control the water flow in the system. Its primary functions is convert from the mechanical energy generated by the rotational motion of the shaft into fluid energy and pressure. The basic components of a continuous pump that include one or more influent plates mounted on a rotating shaft and enclosed within the casing. On the case, an example of a water pump simplify a voltage of 5 volt as depicted in the figure which is used in this IoT project. Turning to the program for interpret voice from humans from board to the board. That is the MCU 8266 development board can be programmed using the Arduino software supported by the Arduino Integrated Development Environment, or in short is Arduino IDE. Turning to for the state of the project is platform that can support the remote control of hardware devices. For the non-MCU board over Internet is the Blink application. The flows that involves like about for four parts. First is the smartphone with the Blink app. Is Blink server. For furniture, like a Blink libraries is used in the code for the non-MCU development board. The smartphone can connect to the internet access, and this setup eliminates the need of to go through a laptop, and there's no need to a laptop to require when during this system to operating. And once the code has been successfully uploaded to the non-MCU board, the Blink app can facilitate direct communication and control from the smartphone to the non-MCU development board over the internet. Drawing of a finished state machine. This cars including like consists of a state finished machine. It returns to the changing from one state to another state and repeating that state again and again. For the first, from starting is the Wi-Fi connections, turning to for the web server start, turning up, and to the ThinkSpeak connection. Turning to this whole operating consists of perm off, perm on, two main parts. For the perm off, if there are no object near the IR sensor, it will continue to in this state that is perm off. If the web server send an on message, the perm off will turn from itself to perm on state, and manually the web server if send an off message in here, the perm on will turn back to the perm off state. And if there in the state of perm off, there are no object. If there are an object near the IR sensor from perm off, it will turn into perm on for the customer to use water. This is here when there's something near the faucet and the water become flow for customer to use. And perm on, if there are no object, it will turn from perm on to perm off. And similar to the perm off state, the perm on, if there's an object near the IR sensor, we continually at the state, this state perm on finished state machine. And this is the diagram related to this. For the project general design, it will consist of several parts in this picture. A box in here. This is a container housing all the necessary components of the automatic water system. A hole where to connect the wire from the SP8266 to the infrared sensor and the water pump. This is the horizontal side of the box when closed. Turning to the top side of the box when closes, there will be a LED. A LED is a light emanating diode indicating the status of the water pump. It lights up when the water pump is active and turn off when the water pump is off. Similarly, from the inside of the box when open, there will be a relay. A relay is a switch to use to control the on-off operation of the water pump. The breadboard circuit for connecting all the components together through wires. Yeah, and there will be two pins for power supply providing the energy to an entire system. An ESP8266 circuit board control for the whole system. And from outside the box, there will be an infrared sensor will be attached to the hand washing sink and to the user detecting partially controlling aspect of the system. And from here, the source water will come through the water pump if there is user connecting to using the water hand washing, it will be population from waters for them to use. This is for general design. And turning to the project circuit diagram, there will be all this part. For the first is the not MCUSP 8266 like I mentioned before. The B is for the LED in here, serving as an indicator on when the LED is on, and conversely, when faucet is off, the LED will go off. For C is the infrared sensor, act as an object detection device at the front. If then object detected in front of the sensor, the water will turn on, and otherwise it will turn off. For D, it is the relay to control the automatic on-off operations of the system. E for the water pump, water draws water from the source to the sink. And F is the source water preferred at the initial water supply. G is the hand washing basin. It is a fixed device with a bowl-shaped water pipe for hand washing, dishwashing, or other purpose. And H is the water for use represents the water that has been pumped from the system for user to utilize. There we can turning to some experiments I have conducted in this project IoT automatic water system. For the project solutions I have mentioned in this board, there will be three options and there will be a one selected options for the final project. The first component is the development board from not MSU is B8266. Option 2 is Arduino Uno R3 with the Wi-Fi shield. Third is the ESP832 and I've selected the not MCU 8266 with a low price and commonly used. For the infrared sensors, two types for the active and passive. I will choose for the active where it's commonly used and which the price is much lower than half. And relay where will be DC power supply, AC power supply, and both DC and AC. I will choose for the AC for the easy integration with the conventional electrical system and equipment. For the term water pump system, WaterTap, mini water pump, brake chip, residential with the integration van 22 VDC, which is very high price, and for the 12 VDC, which is very high. So I turn for the safety option that will be mini water pump. For the water house type, there will be only one option for the 10 and 12 solutions. Very common. For the breadboard, I have chosen that a mini breadboard, which is very common use and suitable to meet the needs of the users. Web service for both local and cloud for supplying this project. Power source, we will choose for the local electrical outlets where low price and easier to set up. There will be options, development options for the customers to use it by battery attached to the system when you can replace after the battery run out for very easy. For the LED that we RGB LED, very low price. And finally is a box containing the equipments, which is the products were available on the market where we can very easy to find out, suitable to meet the need of the users. That is some solutions I have conveyed for these projects. For requirements specification document, three types related to this project. The first is the web mobile app support for monitoring that will toggle for the water system on and off from the desktop computer or from a smartphone. Very easy from the Blink app. And they will track water usage frequency for the easy management on a cloud-based application. Secondly, that is self-watering capability. The automatically initiates the hand washing process without the user intervention. All electric components will be enclosed. Consolidate and protect all the electrical components within independent enclosures. What I've mentioned, like the box, have bought for this project, and very convenient installation system on the easy management. And also, there will be a shield for components from external impacts and harsh environments. For some demonstrations for this project, I have finally built and set up programming also this final project. For three pictures I have shown here. The first one is outside and taken from the side of the box. From the up, taken from the top and bottom, also on the outside for figure 2. And figure 3, that's it from the inside. When open the box will be taken from the side of the product. I will deploy the image from PC and for the smartphone for the users to use them remotely. For the security system for this project, the first is utilizing the local Wi-Fi connections. This is specifically the system utilizes a local Wi-Fi connections. Initially, the circuit board operates as an access point. In here, it means that the device broadcasts its own Wi-Fi network with a specific SSID, and a smartphone connects to this access point using the Blink application, initiating the direct communication. The Blink app will request the name, the SSID, and the password of the desired Wi-Fi network for the device to connect to. The device will then use the provide Wi-Fi authentication information to establish a connection. Upon its successful application, the device is added to the Blink application account and become ready for online user. Second one is the device authentications. The to be specific, the only trust device are permitted to exchange data. The system to ensure that the security by authenticating the devices, allowing only trusted device to engage in data exchange. And yeah, please note that the above data outline the security measures taken, emphasizing the utilizations of a local Wi-Fi connection and device authentication to maintain the system security. When mentioning the IoT devices, there are two types, the Blink Inject and Blink Arc. I've mentioned in the pictures. And for the Blink Inject, this is a microservice that provides the support for verifying ownership rights of user and organization, supplying devices with Wi-Fi login information for connection to the end user Wi-Fi connection, managing the authentication token codes, and user will experience the flow to good and user through the ownership verification process and provide assistance through the Blink app. For the Blink.org, this is a microservice tool for with a different purpose for the user management, including like the user registration through invitation via email addresses, like somehow like that, and managing the roles and permission for each individual within the project. I will have recorded video demonstrations finally for this project. uh, you can go to the link for seeing this how this system can operate and connecting online to the IoT project. So to summarize this whole system, in conclusion, the project will serve as a prototypical model showcasing the transformative impact of IoT on water conservation in daily life and accessibility to technology. First of all is the automatic faucet concept. The automatic water concept that's based on the ESP8266 circuit board addresses the current concern by reducing the unnecessary water usage and ensuring the hygiene, especially in public places. Cost effective doing it yourself assets. The assets that's utilizing the ESP8266 board contribute to the widespread accessibility of advanced technology, making it more widely and adopted, particularly in doing it yourself projects. Integrated IoT functionality. The smart system incorporates the IoT technology, allowing real-time tracking of faucet uses. This feature accurately captures user habits, contributing to the efficient water management. And finally, to emphasize on sustainability, with the society increasing prioritizing sustainability and technology advancement. The project underscores the role of IoT in aligning with these priorities. This project not only introduces you the innovative solution for water conservation, but also emphasize the role of IoT in shaping a more sustainable practice in line with evolving social environments. For the assessment of the projects related to, which also have been done. And in this for some references have been used for these projects, we conclude in this presentation soon. And this is the end of my presentation. Thank you for your watching, and please, if you have any questions, you can contact me as this email as any questions. Thank you for the watching, and I wish you have a nice weekend. Yeah, thank you.